key features of a parabola, and we are going to use a graphing calculator when needed. So using only a graphing calculator to assist you when needed, complete the table, round irrational numbers to the nearest tenth of a unit. Okay, here we go. So here's an example of how to do the first one. Here's our second one. Okay, what is the equation for the axis of symmetry? Well, let's write x equals. Because all of our quadratic functions are parabolas that open up or down, and they all are, as all parabolas are, they're all symmetrical, and they're cut in half by a vertical line. Quadratic functions are cut in half by a vertical line that cuts through the x-axis. That's why it's all x equals, okay? So in fact, all of these, you're welcome to write x equals. Now, how do you come up with that? So off to the side here, if you need to, write x equals negative b over 2a. That's the equation. But in some quadratic functions, in the form that's provided to us, we can actually just pick it out from the form. So this is a vertex form. In vertex form, we can look inside the parentheses, and it gives us a vertex of negative 1, 9, negative 1, 9. So find the vertex and write negative 1, 9. And remember, the vertex will always be on the line of symmetry. The x number here is always the same as the number that goes with the equation for the axis of symmetry. Always, always, always. So look down at this one right here. What will this be? This will be x equals 4, because this is 4, negative 15. Okay? Let's come back here. What is the y-intercept? So y-intercepts always have an x value of 0. So when I plug in 0, and we can use a graphing calculator here, I'm looking at this equation, I'm substituting 0 for x to get a y value. So I'm going to start by putting this in parentheses. Parentheses, negative 2/3, and then I know I have 0 plus 1, which is 1 squared, plus 9. Okay, now here's the deal. You need to know the difference between rational and irrational. It only asks you to round to the nearest tenth if it's irrational. How do you know if something's rational or irrational? Turn to your partner, 10 seconds. What's the difference? A misunderstanding is some students believe that irrational means it goes on and on and on. That's true about irrationals, but irrationals are decimals that go on and they have no pattern. If it has a pattern and you can predict the next number with confidence, it means it is rational. So how do we put this into a fraction so we don't have to round? Hit the word math on the left-hand side. Fraction is highlighted and press enter twice. We're going to write down 25/3. How do you find x-intercepts? How do you find x-intercepts? Well, for an x-intercept, the y is always equal to 0. So I'm going to put a 0 here for the y. And I need to do some math off to the side. But it's asking us to use a graphing calculator. So are you ready? Here we go. Grab your graphing calculator. I believe this is something you're taught freshman year. And we're going to slow it down now because this is something you're going to use the entire year. So hit y equals, and we're going to type in parentheses, negative 2/3. And then parentheses, x plus 1, quantity squared, plus 9. Hit the word graph. You can see that there's two x-intercepts. As a review from last week, we learned that another word for x-intercepts is real roots. So there's two real roots, two x-intercepts. And I'm asked to get the answers for them. So this is brand new to you. Some of you, again, may have learned this on a Casio freshman year. Please make sure no talking to cursor, everybody can hear. I want to know exactly what is this answer and exactly what is this answer. Okay, to do that, let's go through this very slowly so you don't feel lost. Hit second trace. A third term for x-intercepts is 0. So up here, let's write this down. Write 0 and write real roots. Those are all interchangeable words for the same thing. So instead of saying x-intercepts here, it uses the term 0. It's interchangeable with x-intercepts. Go down to 0 and press enter. We're going to be given 3 different commands. I want to start here. Let's look where are we right now. Whenever we start, we're on the actual y-intercept. Do you agree the y-intercept is right here? I need to get very close to this. So we're going to use the arrows here, and I'm going to go to the left, and I'm going to watch this get really close to the x-intercept. Okay, now, ready for the difficult part. I want to know if you were right here, and let's say that you are in a car, and I said, hey, go to the left. I'm saying that because it says left bound. Go to the left. Would you, in this case, be going down if you stayed on this road? Would you be going down or going up if I said go to the left? Down. So I want you to go slightly below the x-axis and press enter 1 time. Now the directions ask you to go right. So again, if left was below, in this case, right is above. So go slightly above and press enter. And lastly, the directions say go over the top of the x-axis as close as you can. And it says guess. Press enter 1 more time. We are going to round this answer. So just so you know, if a decimal stops and it terminates, we say that it is rational. In this case, they are probably rounding this, so we're going to round this to -4 point to the nearest tenth, -4.7. -4.7. You will use this as an entire year. The next 2 years while you're in high school, you'll be using this concept. I've only done one part of an example. Can you do me a favor and raise your fingers? 1 is I'm completely lost how we found that point. 5 is I was able to follow you. 1 through 5, how well are you doing right now with me? So most of us are 2s and 3s. Okay, here we go. Now I need to find this point. Okay, please do second trace and go to 0. Second trace, go to 0 and press enter. So picture yourself in a car here, but let's first take this car and go as close as we can to being over the top of the x-axis. Don't press enter, just go somewhere really close to the x-axis. Okay, so you're in the car, and the directions say go left. Does that mean in this case go above the x-axis if you had to go left or below? So go somewhere above it, and press enter. And now the directions say to go right bound, which in this case is below it. So go somewhere below it and press enter. And the final direction says to guess. So go over the top as close as you can get to the x-axis and press enter. Again, we are going to round. So 2.7, 0. Does this particular parabola happen to have, does it happen to have a maximum or a minimum value? Okay, put your pen or your pencil on top here. Do you consider this to be the very highest point of the graph or the very lowest? Highest, so it's a maximum value. Now, I'm going to show you on the calculator how to get this, but let's cheat first. What is this ordered pair? We know because it was in vertex form. This ordered pair is -1, 9. So what is the maximum value? It is? Okay, but now I'm going to show you if you didn't know that. Okay, you ready? We want to find the maximum. Grab the calculator again, hit second trace, and go to maximum. And can everybody see how I can't see the top? Do you have the same problem right now? What I would really like to do is I'd really like to take this and I'd like to move it up so I could see the top. To do that, hit Windows. I want to take the Y value and I want to push it up so I can see. So hit Windows and find the Y maximum. Right now you're only going as high as 10. Let's go up to 20 to give us a little better view of this. I changed only the Y maximum to 20 and then hit graph. Do we now have a better view of the top? Okay, let's try again. Let's go second, trace, maximum. And before I do anything, let's go to the very top. And what does the directions say right now? Okay, you're in a car and you have to stay on this road. So the left would be somewhere over here, somewhere to the left of what we perceive to be the very top. And press enter one time. Then the directions say right bound. So go somewhere to the right of what you perceive to be the very top. And then it says guess. So guess what you think the very top is. Go to that location and press enter. Okay, this is the same as -1. Okay, this is the same as -1. So -1, 9. Okay, that's correct. That's our vertex. And which value represents the maximum value? It would be 9. Is there a minimum value? No. So let's write NA. What's another word for real roots? X-intercepts. What's another word for real roots and x-intercepts? Zeros. So how many real roots do we have? 2. With your partner, you're going to fill out this line. I'm going to do the exact same thing on my graphing calculator shortly. I'm going to give you right now with your partner 2 minutes. Begin. Okay, I do not expect you to be done, but I'm going to ask real quick that you stop working with your partner and look up here. Anytime I can do a problem and I don't have to use a calculator and it's quicker by just visualizing it and analyzing it, I'm going to go ahead with that step. So in this case, my vertex is +4, -15. Okay? And remember, your x value for the coordinate is the same as the number you use with the equation of the axis of symmetry. All right, so I've got that done, I've got that done. I'm going to come to these in a little bit, but let's come over here. Does this parabola open up or open down? It opens up. Put your hands in this shape, it opens up. Does that mean that my vertex is a minimum or a maximum? Okay, go along here, go to maximum, write NA. What number here represents the maximum value? Oh, sorry, what number represents the minimum value? So y equals -15. Quick review. With quadratic functions like this or like this, turn to your partner. Quadratic functions can only be in these shapes. How many y-intercepts will you have? Always, always, always 1. Quadratic functions, how many x-intercepts will you have? 0, 1, or 2. If that's confusing to you, let's make a little picture up here. I'm going to draw three very simple shapes. And I'm going to draw a picture. Okay, if it had 1, it means it comes down, it hits the x-axis, and it bounces off. Only one place. If it has 2, it cuts through in 2 places. If it has no x-intercepts, it never touches the x-axis. Example of 1 x-intercept, 2, and no x-intercepts. All right, let's plug this into our calculator. 3 times the quantity x minus 4, quantity squared, minus 15. Now, when you look at this graph, you've graphed it. Do you see how I can't see the bottom? It would be really nice right now if I could take this y part and pull it down so I can see. I know I have to at least go to negative 15. So I'm going to hit window, and I'm going to find the minimum y, and I'm going to do, let's try negative 25 just to ensure I have enough space to see the graph. Can I see everything right now pretty easily? Okay. What do I still need to fill out? Well, I'm trying to give you helpful hints. I'll wait till it's quiet. After you graph this, here's your helpful hint. The very first time you hit trace, please do that. Every single time. The very first time you hit trace, you will always see what the y-intercept is. So the y-intercept is 0, 33. How many x-intercepts do we see? Remember, that means there's 2 real roots. That means there's 2 zeros. So let's put a 2 over here. Now, how do we come up with those? Let's go second, trace, 0. Second, trace, 0. Okay? So we are starting right here. We're starting right here, and I want to ask yourself, if this is your road, I'm way up here. I need to come down. Okay, so I'm going to get really close to the x-axis. If somebody said to you, okay, you're really close, but I want you to go to the left, because the directions say to the left. You're in this car, you're on this road. Is to the left, in this case, above or below? It's above, so go somewhere above, slightly above, and press enter. Directions now say right bound. In this case, it's below. Press enter. And guess means go over the top of it as close as you can and press enter. Rounded to the nearest tenth would be 1.8. Okay, let's do this one. Second, trace, again 0, because 0, x-intercepts and real roots are interchangeable. Take the little cursor, come all the way up here. Okay, good. Now ask yourself, if you're in a car and you have to stay on this road, is left bound below in this case or above? So go below, press enter. Right bound in this case is above. Press enter. And guesses go over the top. Sometimes you're not going to be able to go directly over the top, but as close as you can. And press enter. And rounded to the nearest tenth would be 6.2. Okay, I want you to help me right now. 1 through 5, not based on speed, but if you've been here from the beginning of the lesson, your understanding of how to get these answers using the calculator. 1 through 5, so I know where we are. Wow, most of us are 4s and 5s. That's really impressive, okay? So this is vertex form. Let's do one right now that's in standard form. Again, we get to use a graphing calculator to make our lives easy. So let's do second plus 712. That's going to erase everything here to start again. Second plus 712. It clears the RAM. Go up to y equals, and let's plug in this problem. X squared plus 5x plus 7. X squared plus 5x plus 7. Hit graph. How many x-intercepts do we have? 0. Does everybody see how this never touches the x-axis? So let's go over on this here. Let's go over to x-intercepts. There's 0. And go to x-intercepts and write NA. There's none. Or you could put 0 again. I just don't want that to be confused with what an actual x-intercept is. There's none. Okay, so let's start by doing this. Let's start by figuring out what is this vertex. Put your hand like this on the video. It's like this, so it's going to mimic this shape. Is this point, the vertex, considered a minimum or maximum? Minimum. Okay, it's not a maximum, so let's go to where it says maximum, and let's write NA so there's no confusion. We know it's going to be a minimum point. Now, how do we figure out that minimum point? Do second trace, go to minimum, and press enter. I want you to take the little cursor and go over the top of where you think the minimum is. And then we're going to follow directions. If you're in a car and you're on this road and you get to the very bottom and now it says go to the left, that would be somewhere over here, and I press enter one time. Then it says go to the right, so I go somewhere to the right of what I think the lowest point is. Then I go over to the top of where I think the lowest point is and I press enter. Okay? And so we are going to write down, I think for this, because it's not a long decimal, we can write down the exact. So this is our vertex. Let's go negative 2.5 and 0.75. Negative 2.5 and 0.75. Now, just so you know, for homework, I asked for rounded to the nearest tenth if it's irrational. This is not irrational. It terminates. That's why I put this entire decimal. Is it the x or the y that determines the minimum value? Y equals 0.75. Okay, and which one of these numbers do I associate, the x or the y, with the line of symmetry? Negative 2.5. Now, let's make life easy. I want you to go back and hit trace. We got to start again. Go back and hit graph. Hit the button graph. And now hit trace. Oh, it's not doing it for me. Darn it. I should have done it right away. But you know what? I don't have to plug it in because remember, when I look at a function in standard form, which number here tells me what the y-intercept is? The 7. 0 for the x and 7 for the y. Let's find one that's in factored form. Please go all the way down to this problem. Let's write x equals. And let's plug it into your graphing calculator. Let's start by doing second plus 712. I'll give you a chance to plug it in. Okay, so I'm going to type in here x minus 3/2, which is 1.5, and then x plus 5. And I graph it. Does everybody see how I cannot see the bottom? So it'd be really nice if I could take that y and I pull down the y so I could see the bottom. So let's go up to, let's make our lives even easier. You ready? So if you've not touched anything, just hit trace once. What is the y-intercept? 0, comma, negative 7.5. 0 and negative 7.5. Now I want to take the windows here and I want to adjust it so I can see the bottom. So if I hit windows and I go to y minimum, I want to pull down the y so I can see it. Let's go to negative 20 for the y minimum and then hit graph. Now we have a better view of this. How many x-intercepts do we have? Okay, so along this line I'm going to come over and hit 2. So my hand right now mimics what I see on the actual graph. Is this vertex considered a minimum or a maximum? So along this line, I go to maximum and write NA. Now let's figure out what this actual vertex is. Second, trace minimum. Take the cursor and go to the very lowest point, and then follow the directions. Go left bound, enter, go right bound, enter, and at the very spot, and press enter. And this is a little bit longer than we'd like, so let's round this to the nearest tenth. We're just getting the main idea of here of how to come up with these numbers. So here we go. We're going to have a vertex right now of negative 1.75 and negative 10 point, we'll say 10.6. And you may be wondering, well, Miss, how do I know when I round to the nearest tenth or the nearest hundredth? Right now, as long as I see you're getting the, if you put negative 1.8, I won't count it wrong. If you put negative 10 points, you wrote the whole thing out, I wouldn't count it wrong. I just want to make sure you're getting the right number down, okay? All right, and I'll be more specific prior to taking a checkpoint quiz about how to come up with this and how to round. Okay, so from this, which number do I use to associate with the equation for the axis of symmetry? Negative 1.75. Which one of these represents the minimum value? Negative 10.6. I know there's going to be two x-intercepts. And remember, for x-intercepts, your y value is always 0. Okay, so here we go. We are going to do second, trace, and we're going to find the zeros. Second trace, find the zeros. Let's start at the very left-hand side. Go over the top right now. And you're in a car, you're on this road and it says go to the left. Would that be going up or going down in this case? So I go up above it somewhere and I press enter. Follow the directions, go down below it somewhere, press enter, and back over the top and press enter. Negative 50 is one of the answers. Okay, we're going to do the next one. Second, trace 0. And I'm going to take the cursor here and I'm going to continue to hold it down until I get to the next x-intercept, and I'm going to follow the directions. Left bound, you're in a car and this is your road. Is left bound below or above? So go somewhere below, press enter. Go somewhere above, press enter, and now go over the top and press enter. And 1.50 is the other.